All right, you've already been studying about right triangles in your geometry class, and today we're going to look at some special cases of right triangles. As you can see here on the screen, there are different sizes of right triangles, and you can tell by all of these that a right triangle, of course, has a 90-degree angle, a right angle, and then the legs of the right triangle are represented here with an A and a B, and the letter C is representing the hypotenuse of each right triangle. So you can tell, for instance, on this larger triangle to the right, that leg B looks like it's probably longer than leg A, and that's fine. The legs don't have to be the same length. And on some of the others, it may look like that A and B are the same size, the same length. So what we're going to be looking at today are special types of right triangles where the legs are congruent to one another. A diagonal of a square divides it into two congruent isosceles right triangles. Since the base angles of an isosceles triangle are congruent, the measure of each acute angle is 45 degrees. So another name for an isosceles right triangle is a 45-45-90 triangle. A 45-45-90 triangle is one type of special right triangle. You can use the Pythagorean theorem to find a relationship among the side lengths of a 45-45-90 triangle. All right, here's a theorem. It's your 45-45-90 triangle theorem, and it just says that in a 45-45-90 triangle that the legs are congruent, which makes it isosceles, and that the length of the hypotenuse is the length of the leg times the square root of 2. So look at this picture here. You can tell that the legs are congruent to each other. They're both represented with the letter L. And the hypotenuse is just going to be the length of that leg times the square root of 2. Here's our first example. Find the value of x. Give your answer in simplest radical form. Well, since you know that that this is a right triangle because of the 90-degree angle, and that one of the two acute angles is 45 degrees, you know that the other angle must be 45 degrees, the missing angle. And this makes this an isosceles right triangle, and you can use your theorem to find the length of the hypotenuse. Well, one of the legs is 8, which automatically makes the other leg 8. So what would the length of the hypotenuse be? Well, by the theorem, it says that the length of the hypotenuse is going to be the leg times the square root of 2. So that's going to be 8 square roots of 2. All right, you try example B, and we're going to pause the video just for a minute and let you have just a second to figure this out on your own. Now this one is a little different because this time you're given the hypotenuse. Notice that you're given the side that's across from the right angle, which is the hypotenuse. You kind of got to go backwards here and to find the length of each leg. Now you know it is an isosceles right triangle because both legs are represented with the variable x, so they must be the same length, which makes this an isosceles right triangle. All right, so let's see what we have here. All right, we know that the hypotenuse is equal to a leg times the square root of 2. So we can set up a little equation for that. The hypotenuse 5 is equal to x, which is the leg, times the square root of 2. Well, to isolate x and get it by itself, we have to divide both sides by the square root of 2. And when you do that, you get 5 over the square root of 2. And if you type that into your silver calculator, it's actually going to rationalize the denominator for you. And you're going to get 5 square roots of 2 all over 2. Now, the point in doing that is that we don't want to leave a radical in the denominator of our fraction. So we want to get the square root of 2 out from underneath the fraction bar. All right, one more example. I'm going to give you just a few minutes to try this one on your own. All right, so this time we're finding the value of x, which is the hypotenuse of this isosceles right triangle, because it's across from, or opposite of the right angle. By the triangle sum theorem, the measure of the third angle in the triangle is 45 degrees. That's going to be actually the two acute angles. So this is a 45, 45, 90 triangle, also known as an isosceles right triangle. And one of the legs is equal to 10 square roots of 2. So we're going to start with that same equation, that the hypotenuse is equal to the leg times the square root of 2, and then just substitute in what you know. Well, we know the hypotenuse is x, and one of the legs is the square root of 2. So x is equal to 10 square roots of 2 times the square root of 2. Simplify to get a value for x of 20. Because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is just 2. And then when you multiply 2 times 10, you get 20. Again, your silver calculator will do that for you. All right, so our hypotenuse here is 20. All right, here's an application exercise. So let's read through this. Jana is cutting a square of material for a tablecloth. The table's diagonal is 36 inches. She wants the diagonal of the tablecloth to be an extra 10 inches so it will hang over the edge of the table. What size square should Jana cut to make the tablecloth? Round to the nearest inch. So I'm going to give you a minute to maybe draw this picture out and take a look at this and see if you can come up with it. All right, so what Jana needs is a 45, 45, 90 triangle with a hypotenuse of 36 plus 10 inches. Because if you think about this, the diagonal of the square tablecloth is the hypotenuse of the two triangles that are formed. So again, we're going to use the same equation as earlier. The hypotenuse of an isosceles right triangle is equal to the leg times the square root of 2. All right, so we're going to substitute in what we know for the hypotenuse, which is going to be 46. And we don't know what the leg is, so here they're going to let that represent that with an L times the square root of 2. Now, to get L by itself, we have to get rid of multiplying by the square root of 2. So we do the inverse operation of dividing by the square root of 2. And since they told us to round to the nearest inch, we're not going to keep it in radical form. We're actually going to type this in our calculator and get an answer for it to the nearest inch. So this should round out in your calculator to 33 inches.